Good afternoon, class. So let's begin with our topic for today, which is going to be trigonometric functions. Now, I know this is a completely new topic, and for those of you that would not have been present for my Zoom session, hopefully the notes along with this video will provide you all with some guidance on how to approach this new topic. So we began trigonometry, started off with Pythagoras' theorem, and now we're going to go a little bit deeper into our trigonometric functions. So before we even get into anything, I have some terms that I want to make sure that we're all familiar with. So we would have been familiar with the term hypotenuse from even before we started this video, because we would have done hypotenuse when we talked about Pythagoras' theorem. So hypotenuse is simply that longest side in a right angle triangle, or basically that side that's opposite a right angle. We also have the opposite side. So we have the opposite, and opposite is just as it is, the side that's directly opposite to the given angle. So opposite is the side that's directly opposite to the given angle, and then we also have our adjacent side. So our adjacent side is that side that is right next to the given angle. So let's look at an example of a right angle triangle, okay? So this is a right angle triangle here, and let's say this is 20 degrees, and we had three sides here. So right away, we should be able to automatically identify that x is our hypotenuse. We should definitely be able to identify that x is our hypotenuse, because remember, the hypotenuse is that longest side that's inside of our right angle triangle, or basically that side that is directly opposite to our right angle. And we can see this is our right angle. Let's change the color so that you all can see that there. So I'm shading over our right angle, and we can see that this is literally the side that's directly opposite to our right angle. Okay, so now let's move on. Let's move on to the other sides now. So we have our opposite side now. So when we're talking about opposite and adjacent, when we're talking about these two, because we all should definitely know how to identify the hypotenuse. So when we're talking about the opposite and adjacent, we need to look at the given angle. Okay, so this actually varies. This varies with position of given angle. So for example, our given angle here is 20 degrees. So this is our given angle. So we're going to look at the sides. Now, if we're trying to identify the opposite side, we know this is where our angle is. So if we're looking for the side that's opposite to this angle, we're going to say directly opposite to this angle is y. So therefore, we can actually identify that y is our opposite side. So y is our opposite side. And now we're going to try and identify our adjacent side. So once again, our adjacent side depends on where our given angle is. So our given angle is still 20 degrees because it's the same triangle. And we're simply going to look for the side that's right next to this angle. So the side that's right next to this angle is actually this side here. We can see that it's literally, this is the angle here, and this side is literally right next to this angle. So therefore, our adjacent side is going to be z. So z is going to be our adjacent side. So that's the first thing we should be able to recognize. So if I give you any right angle triangle with this topic, you should right away be able to identify what's my hypotenuse side, what's my opposite side, and what's my adjacent side. So let's look at another example, because like I said, the opposite and adjacent sides do vary with the position of your given angle. So let's look at another example. Okay. Yes. So we're going to draw another right angle triangle. So let's say this is our right angle triangle. But this time, let's say this time our given angle is located here. So let's say this is 20 degrees again. Now you realize that in this case, our hypotenuse actually remains the same because we know that the hypotenuse is that same side that is opposite to our right angle. So if our right angle is here, opposite to our right angle is going to be this side right here. And let's just label it so we can all be certain. So over here, this is our side A. So over here, this side is our hypotenuse because that's the side that's opposite to our right angle. Now, we're going to look for our opposite side. So our opposite side is simply that side that's opposite to our given angle. So our given angle was 20 degrees. So opposite to that 20 degrees is going to be this B here. So therefore our opposite side is B. And then finally our adjacent side, we're simply going to look for that side that is literally right next to our given angle. So that is going to be side C. Okay, that's going to be our side C. So therefore our adjacent side is simply C. Okay, so that's how we are able to identify what side is our hypotenuse, what side is our opposite, and what side is our adjacent. Now it's all going to make sense in a bit because I'm sure you all are probably wondering what's the importance of being able to recognize which side is which. So now here we're going to introduce you all to our trigonometric ratios, okay? So I'm just going to write something here. So let's try and pronounce this. So this here is actually pronounced SOHCAHTOA, okay? SOHCAHTOA. I'm just going to leave this right there and it's going to make sense shortly. Okay, it's going to make sense shortly. I'm just going to leave some space for this, okay? So we're going to leave some space. Now, there are going to be 3 trigonometric ratios that you all will be exposed to. So the first one is sine. The second one is cosine. And let me just spell it. In the calculator, you will see SIN, but let me just spell it by its proper way. And then we also have tangent, okay? So those are our 3 trigonometric ratios that you're going to see with this topic. Sine, cosine, and tangent, okay? Now, all this says is that sine, let's put a little sign here for angle. So sine of angle A is equal to the opposite side over hypotenuse. We're going to say cosine of angle A is equal to adjacent side over hypotenuse. And these are some math formulas that you have to know. And then finally our tangent of angle A, and angle A is just simply any angle that is given to us. So tangent of angle A is simply equal to opposite over adjacent, okay? So tan angle A is equal to opposite over adjacent, okay? Now, let's go right back to our SOHCAHTOA. So, an easy way to remember this is that we have sine. Sine begins with S. So, we have S here. This is for sine. Is equal to opposite, which begins with O. So, it's equal to O, and we have our O here. And then we have H for hypotenuse. So sine is equal to opposite over hypotenuse. That's one side here. Then we have our cosine. Cosine begins with C is equal to A for adjacent. We have A over here over H for hypotenuse. And then finally we have our tangent. So tangent, this is our T for tangent, is equal to our O for opposite over A for adjacent. So therefore, if you're ever wondering how am I going to remember these things, you use your SOHCAHTOA. So SOH tells you that sine is equal to O over H, which is opposite over hypotenuse. Ka tells you that CAH. So your cosine is equal to A over H. And then finally you have TOA, which tells you that T is equal to O over A. So SOHCAHTOA. SOHCAHTOA helps you to remember these, and it won't be difficult as you get more and more practice with these, okay? So now I'm sure you're wondering, where exactly does this come into play? How is this relevant? How is it relevant to know your opposite and hypotenuse and your adjacent side? How is it relevant to anything that we have to do in trigonometry? So one way in which these trigonometric ratios helps us is when we want to find a missing side. So we have a missing side that we want to find. So a missing side, and that missing side can be any letter because we know that any letter means an unknown. So when we have a missing side in a right angle triangle and we have one known side, and then we have one known angle. So we have a missing side, we have one known side and one known angle. So therefore a question can be presented as simple as something like this. So we have our right angled triangle. We have let's say this is 38. Let's say that this is 4 centimeters. And then now let's call this our x, okay? That's an x in this corner here. So we have our known angle. So we have our known angle, which is 38 degrees. We have a known side, which is 4 centimeters. And we have our missing side, which is x. So therefore, we can actually solve for x using our trigonometric ratios. So we're going to do this by simply following some steps, okay? So step 1, we need to decide which trigonometric ratio to use. We have to decide which trigonometric ratio to use, okay? So I'm going to write this. I'm going to say step 1. Step 1, we're simply deciding, determine which trigonometric ratio to use. And we have to remember that this depends on which two sides are involved. So that's how we determine which trigonometric ratio to use. This depends on which ratio is involved, okay? So we have to determine which trigonometric ratio to use. Now, with this, after we determine which in order to determine which trigonometric ratio to use, we have to look at what sides are involved in this question. So there are two sides that we have information for. We have information for this side, and we also have, even though we don't know what this side is also involved. So let's try and identify what would we call this 4. We know definitely this 4 is not our hypotenuse because this here is our hypotenuse that we're not using. We know that it's not our opposite because this 4 cm is not opposite to this 38 degrees. So this 4 cm is actually our adjacent, because we know that this side is literally the side that's right next to our given angle, which is our 38. And then here we know that the x is actually our opposite side, because this x is literally directly opposite to this 38 degrees. So this is our opposite side. I'm just going to try and put a little O for opposite. So that is an O there. Let me make that a bit better. I'm just going to draw an arrow. Okay, I'm not sure why this is. Okay, let me just draw. So I'm just going to draw an arrow and say that this x is our opposite, and then the 4 is our adjacent, okay? So we've identified that the two sides involved are our opposite and adjacent. So which trigonometric ratio involves our opposite and adjacent? So if we remember SOHCAHTOA, we remember that our tangent, we remember that tan angle x is equal to opposite over adjacent. So right away we know that this is our ratio involved. So we're going to use our tan ratio for this question. So tan angle x is equal to opposite over adjacent. So now that we know that, we're going to simply substitute. All we have to do now is substitute. So therefore, step 2, okay, let's pull up some text. Okay, so step 2, all we're doing in step 2 is we're going to set up equation using chosen trigonometric ratio, and we substitute. Okay, so that's our step 2 right there. So we simply set up equation using chosen trigonometric ratio, and we substitute. So by that, all we're going to do is simply, we already know that tan of angle x is equal to opposite over adjacent. That's what we would have discussed earlier. So all we're going to do is substitute now. So we're going to say tan. We know that angle x is actually the given angle. So therefore, angle x is 38 degrees. The only angle that was given is equal to our opposite side. We know that x is our opposite side. So we're simply going to say x over, and we know that 4 is our adjacent side, which is over here. So we have over 4. So now we have step 3. So step 3, we're simply going to solve for x like a regular algebraic equation. That's all we're doing. We're going to solve for x like a regular algebraic equation. So the first thing, because we have fractions involved, our first job is to turn this tan 38 as a fraction. And we know if we want to turn any given thing as a fraction, all we can do is simply put it over 1. So all we're going to do is say tan 38 over 1 is equal to x over 4. And now when we have two fractions separated by an equal sign, all we have to do is simply cross multiply. So when we cross multiply, we're going to have x. Okay, yes, when we cross multiply, we're going to have x times 1, which gives us x is equal to 4 times tan 38. So what we're going to do in our calculator, we're simply going to enter 4 times tan 38. So all we did was simply put in our calculator 4 times tan 38, and then show that your calculator is in radians. So when we say 4 times tan 38, we have 3.1, and we're going to round it off. So we have 3.13 centimeters. So that is our answer. We have x is equal to 3.13 centimeters. So we got this 3.13 centimeters by cross multiplying. We said x times 1, which gives us this x over here. Then in our calculator, we simply entered 4 times tan 38 to get 3.13 centimeters, okay? And that is our solution for that question. So we found our missing side to be 3.13 centimeters. So now we're going to look at another example, but this time we're going to look at an example when x is our denominator, okay? We're going to look at an example when x is our denominator. So let's draw our right angle triangle for the question. So we would have a question, something like this. So we have our question here, and we have, let's say this is 6 cm. Let's say that's 6 cm. Let's say this is, let's call this angle D. And then now let's say, okay, yes, and then let's say that we have, this is 35 degrees. So we have, this here is 6 cm. Let's fix that. Something doesn't look right here. Okay, so this is 6 cm, that's D, and then we have 35 degrees. So the first thing we need to sort out is which trigonometric ratio is used. So if we want to find out which trigonometric ratio we're going to use, we need to look at the question. Look at what are we given. Right away, we know we're always going to be given an angle for the beginning of this topic. So we have an angle that we're presented, right? So if we have an angle that we're presented, now let's look and figure out what's our hypotenuse. Is there a hypotenuse? Do we have our opposite involved? Do we have our adjacent involved? So let's look at the two pieces of information that we were given. We were given this D. We don't know what it is, but we know that it's a part of our question. So therefore, let's try and identify what would we call this D. Is this our opposite? Is this our adjacent? Is this our hypotenuse? Because we know that the hypotenuse is that longest side, the side that is literally directly across from the right angle, we can identify that D is our hypotenuse, okay? And I'm just putting that H for hypotenuse because it's literally directly across, directly opposite our right angle, which is here. So now let's look at our opposite. Let's figure out if this is our opposite or adjacent. Now we know that opposite and adjacent depends on where our angle is. So if our angle is here, we're going to look at this 6 cm. So what is this 6 cm with respect to this angle? Is it next to this angle or is it opposite to this angle? And we can see that this 6 cm is actually opposite to this angle, right? So therefore, we're going to call this 6 cm our O because it's opposite to that angle. So therefore, we have opposite involved and we have hypotenuse involved. So once again, we're going to remember our SOHCAHTOA. So because we have our opposite and hypotenuse involved, that means that we're going to use our sine. So therefore, let's write out our sine. So we know that sine of angle X is equal to opposite over hypotenuse. So now that we wrote down our trigonometric ratio, we want to substitute. So we know that the angle X is our given angle. So angle X is going to be the same angle that we were given, which is 35 degrees. So we're going to say sine 35 is equal to, our opposite is our 6. So we have 6 over our hypotenuse, which is simply D, which we're solving for. Okay? So our hypotenuse is what we're solving for. We're solving for D. So with that being said, we have an equation presented to us. Now, before we do anything with that, we have a fraction on one side. So our first order of business is to turn this sine 35 as a fraction as well. Anytime we want to turn something into a fraction that's not a fraction already, we simply put it over 1. So now, as we've all mastered solving algebraic equations, if we have a side that we want, if we have two fractions, that we want to get rid of, we want to get rid of these two fractions. We have two fractions separated by an equal sign. So anytime we have two fractions separated by an equal sign, we're simply going to cross multiply. So we're going to say d times sine 35 is equal to 1 times 6. So once again, now I know this is going to look a bit different, but it's not difficult, okay? So d times sine 35, we're just going to use our brackets. So we have d, and then we want to put sine 35 in these brackets is equal to 6. Because we know that brackets mean multiply, right? We're familiar with brackets meaning multiply. So d open brackets sine 35 simply means d times 35 is equal to 1 times 6, which is equal to 6. So now we have d open brackets sine 35 is equal to 6. And all this means is that d times sine 35 is equal to 6. So now if we have d times something or something times d, and we want to get rid of that number that's next to the d, because remember, we're trying to solve for d. So all we're going to do is divide both sides by sine 35. Divide both sides by sine 35. And when we do that, we can actually cancel this out, okay? In the same way as if we had something like 2x is equal to 4. All we have to do is to get rid of that 2 that's next to the x is divide both sides by 2. So it's the same concept. Anytime you want to get rid of something directly next to the x or next to the unknown, all we're going to do is divide both sides by whatever we're trying to get rid of. So that's why we divide both sides by sine 35. And now we have d is equal to 6 over sine 35. So in your calculator, all you're going to do is put 6 in your calculator divided by sine, and you have your brackets, sine 35. So when you say 6 divided by sine 35, you're going to get 10.46. And then, of course, because we got it in centimeters, we're going to say cm. And that is all we do to solve for these introductory trigonometric questions. So just a little recap. Anytime we want to find a side, when we have one side given and we have an angle given, all we're going to do is determine which trigonometric ratio to use. And we have to remember that this depends on which sides are involved. And we have to use our SOHCAHTOA. So if our opposite and hypotenuse are involved, we're going to use our sine ratio. If our cosine and adjacent and hypotenuse are involved, we're going to use our cosine ratio. If our opposite and adjacent are involved, we're going to use our tangent ratio, okay? And after we decide which ratio to use, we're going to set it up using our given trigonometric ratio. We have to remember that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, tangent is equal to opposite over adjacent. After we set it up, all we have to do is simply substitute. We usually, for this introductory part, we're given an angle, so this is our given angle, and we have to replace opposite and hypotenuse with whatever it is inside the question. One will be unknown and one will be known. Then after that, we're simply going to solve for x as if it's a regular algebraic equation. So in all of these cases, you will have cross multiplication involved, okay? And that is it.